right, well, we'll get started here a few minutes early, which is great. Thank you all for coming. This is fantastic to see so many people here. Who's native to Pittsburgh? Wow, that's great. Who, so Hillary and I, we are from Oregon, which is the big chunk of land between San Francisco and Seattle, for those of you that aren't aware of US geography. Where's everybody from? I'm just curious. Like, this isn't part of the talk. I'm trying to just Boston. Where?
Portland.
Oregon?
Woohoo! Hi,
Yeah.
friend. Me too.
DC? Awesome. Oh, yeah, that's great. Yeah. Wow. Well, thank you all for coming. Yeah. Wow.
Nice.
Awesome.
Oh, wow. Long flights. Oh, my goodness.
This is fantastic. Who's been to a PyCon before? Right? Who's been to 2? 3? 4? 5? So we're tied. It's great. How many have you been to? Wow. That's great. All right, who now, kind of onto the talk, who is familiar with MCP? All right, it kind of looks like we have some room to be high level and maybe do a little bit of deep dive, so that's great. So again, my name is Ken Alger. I'm a developer advocate at Heroku. This is Hillary Sanders. She is an AI staff, technical staff person. Your title changes frequently, so yeah. So, we'll get started here and kind of talk about a crucial aspect of making large language models, or LLMs, really powerful. And it's their ability to interact with the real world through external tools, right? We've seen the incredible text generation capabilities of LLMs, the integration of LLMs into IDEs that allow for code assistance. Who's been using any of that? Who loves it and it gets it perfectly right every, see, boy, everybody's hands drops really quick there. But imagine extending that to actions, right? Getting real-time data or manipulating systems, automating workflows. Some of those tasks that we do could really benefit from this concept, right? Like booking flights. Who had a perfect trip to Pittsburgh? If you live here, you probably did. I did not. So booking flights would have been great. Querying databases, sending emails. So this talk is, we're going to kind of explore how you can build the infrastructure to enable a really powerful synergy between LLMs and tools. And here's kind of what we'll be covering this afternoon here. We'll start kind of by understanding what the MCP Model Context Protocol is and why we think it's important. We'll dive into building Python-based tool servers that speak MCP. As we grow with our apps and tools and whatnot, scalability is important, so we'll discuss that. We'll see how Heroku, which is where Hillary and I both work, can really simplify the deployment of your apps with this. Hillary's going to do what I'm sure is going to be an amazing demo, and where she kind of puts everything together. And then we'll cover some big considerations and best practices. And if there's time left at the end and interest, we'll do a Q&A. And if there isn't, we have a booth downstairs in the expo hall, and we should be around. But our big goal here is for you to leave this session with an understanding of how to build and scale your own LLM-powered agents. So before MCP, the landscape of connecting LLMs to tools was kind of chaotic, kind of a little bit Wild West, which is kind of why I'm dressed like a fool up here. Every tool had their own way of expecting requests and sending responses. It was very haphazard. And this lack of standardization created really significant hurdles. Integrating each new tool required custom code, right? Increasing complexity and making it harder to build those robust and interoperable AI agents that we all want to try and build. So you can kind of think of it like trying to communicate with someone who speaks a different language every sentence, right? Or trying to build a puzzle with shapes like that and pieces that don't fit, or communicating, as these wacky purple lines suggest, in a random, haphazard sort of way. It's very, very inefficient. So this is where MCP, or the Model Context Protocol comes in. So we'll take a high-level look there and how it can interact with tools. So it's a standard for seamless tool integration and for communication. Kind of think of it as a universal translator for LLMs and tools. At its core, MCP is an open source protocol that defines a standardized format for how AI applications should request actions from tools and then how those tools should respond. Now, to be clear, this is not all that MCP is designed or has protocols for, right? There's things for data sources, a lot of different things. This talk, we're just gonna really look at tools. Now, this standardization of MCP kind of brings a few really important benefits. One is consistency. So regardless of the underlying tool, the LLM can interact in a predictable request and response structure, which is very important. Flexibility. While the communication is standardized, the actual implementation and execution of the tool server can be as flexible as you need it to be. And then ease of integration. Integrating new MCP-compliant tools becomes a lot easier. So ultimately, MCP aims to make building powerful AI-driven AI agents much more manageable and friendly. So this is kind of a standardized request, especially for tools. MCP uses JSON as its wire format, specifically the JSON RPC 2.0. And a typical JSON, or typical MCP request, includes fields like the tool's name or tool name, right? And which identifies which tool the LLM is supposed to be using, and the params value there, which is a dictionary containing the specific data the tool needs to execute the action. Now, the real beauty here is that the LLM only needs to learn this structure for the tool's arguments, right? Your input schema. And this typically gets passed on to the LLM as part of your inference request. And then the tool server can handle the translation to the tool's native API. And similarly, from a response standpoint, the tool server sends back to the LLM, follows a standardized structure. Again, this is all trying to make a cohesive communication system so that everybody knows what's going on. And the key fields in the response often include the content, so containing the output of what the tool's execution is. This could be data, status message, what have you. The is error is pretty typical, indicating whether the tool execution was a success or failure. And this consistent response format allows the LLM to reliably interpret the outcome of the tool call and proceed accordingly, right? So again, it's all about consistency between LLMs and the tool servers out there using MCP. So if we look real briefly how the LLM and tool server kind of connect and interact over time, it's kind of the connection lifecycle. So it starts with an initiation phase where a connection is established, and this could be a persistent connection or a new connection for each interaction. And for some transports like HTTP or the new stateless streamable HTTP transport, one thing I love about tech is the wonderful words that you have to try and pronounce when you're in this stateless streamable HTTP. Anyway, sorry. There's a a vastly simplified request response cycle with the stateless streamless HTTP transport type, and it's compatible with simple curl type requests. For transport types that maintain state, like the Studio and SSE and stateful streamable HTTP, you might have a more involved hand state process here to establish the persistent connection before the request response cycle begins, which brings us to the request phase. And this is where the code that's handling the LLM request sends an MCP formatted request off to the tool server. The tool server processes the request and sends it back in an MCP formatted response. And there's a termination phase where the connection might be closed. So what happens if there's an error along the way? All right, it is possible to keep that connection alive and carry out multiple request responses before the termination happens. Now, there are a lot of different options out there for building tool servers with MCP. Right? I mean, you can use a lot of different languages. Other than the fact that we're here at PyCon, right? And now we're going to talk about Go. No, I'm just kidding. So, why would you choose PyCon to build your tool servers? When it comes to building these MCP-compliant tool servers, Python really is a great choice for several reasons. It has a rich ecosystem of libraries that makes interacting with various tools and APIs very straightforward. The readability and ease of use of Python is something that I think we can all probably understand is a big benefit, and it helps to accelerate development. And specifically for building tool servers that handle MCP, we have frameworks like FastAPI, coupled with the UV Unicorn server, which provides high performance and developer-friendly foundation for things. There is an MCP Python package, which really helps structuring your MCP requests and responses. And the demo that we'll see here shortly will kind of showcase, I think, some of the MCP package features a little bit. And then depending on the tools and the servers that you need to interact with, you might be leveraging libraries like Scicop PG2 for Postgres databases, LangChain for more complex AI workflows, Chainlit for building more interactive LLM applications. So if we look at what a simplified example of how you might implement an MCP endpoint in Python, this is using a few libraries. So FastAPI, request, JSON libraries. But you'll make an MCP call tool request. And you can do that either via the object name or via some other code being used. But you'll typically define a route, right? Your tool server URL with, in this example, it's an MCP is the route. And it listens for post requests because post requests, MCP requests often involve sending data. And within this endpoint function, you'll be receiving the incoming JSON request, parse it to extract the tool name, method, params, that sort of thing. And here you'll probably want to leverage the Pydantic models to define the expected structure of the incoming MCP request, which will provide the automatic data validation for you. And then based on the tool name and the params, you'll then route the request to the appropriate function within your tool server that handles that specific tool logic. Does that kind of make sense, right? And this routing mechanism is key to keeping your tool server organized and maintainable, right? You want those routes to be organized and maintainable. And then after the tool logic has been executed, you'll construct the MCP response, again, often with a Pydantic model to ensure it adheres to the MCP standard. And this is kind of really, connecting to your tools is where the rubber meets the road, or the horse goes down the trail, or I don't know what we want to use here. But the core of your tool server lies in its ability to interact with the actual external tools. And depending on the tool, this might involve making API calls, using libraries like request, interacting with databases, using database connectors like Scicop PG2 or SQL Alchemy, or triggering other processes or workflows. Now, it's really crucial to abstract this tool-specific logic away from the actual code making the MCP request. This makes your server more modular and easier to extend with the new tools. So think of this layer as the adapter that translates the standardized MCP request into specific language and requirements of each individual tool. Now, once the tool logic has completed its execution, right, your Python server needs to format the result back into an MCP-compliant response. This involves creating a JSON object or perhaps a different format if you're using a different transport type. But it's going to include things like the result, which is the output from the tool, a status of success, failure, maybe something else. Again, using Pydantic models here is really going to help ensure that your responses adhere to the MCP standard, making it easy for the LLM to parse and understand, and providing informative error messages in the result when status has failed is also a key to a best practice. I mean, how many of us have gotten an error message that just say, nope? You're like, well, what good does that do? So, and this code snippet here is really just an example in the demo that we're going to see here shortly. Much of this is kind of abstracted away with that MCP package. Now, scalability is something that sometimes is an afterthought when it comes to building applications, but it's an important consideration to keep in mind, especially from the start when you're building your MCP tool servers. So as your AI agents become more popular and handle more complex tasks involving tools, the traffic to your tool servers will inevitably increase. The scalability is therefore a pretty critical consideration, and without proper planning, you can run into several different issues. One is slow responses. Increased load can lead to higher latency, making your AI agents feel sluggish, which nobody really wants. Tools might time out waiting for a response from an overloaded server. Or in an extreme case, your tool server could just become unresponsive and crash and result in a failure. So proactively addressing scalability ensures a smooth and reliable experience for your users. Now, one of the most common and effective strategies for scaling applications, not just MCP and tool server applications, but it certainly includes LLM tool servers, is horizontal scaling, often referred to as scaling out, right? So instead of making a single server more powerful, vertical scaling, you scale horizontally. Add more instances of your application. And to effectively distribute incoming traffic across these multiple instances, you'd need a load balancer, and the load balancer is just acting as a traffic cop, kind of ensuring that requests are evenly distributed, preventing any single instance from being overwhelmed. And when you're using SSE or streamable HTTP servers, that's particularly true. Now, the Heroku platform provides built-in features to scale your application horizontally. Is anybody currently using Heroku, not for MCP tool servers, but using Heroku in general? Wow. All right. So I think there's probably a handful of us in the room. Yeah, so I mean, have people used it in the past? Yeah, okay. Are people familiar in general with what Heroku is? Let's do that. All right, I like the more hands, great. So let's take a quick look and discuss why Heroku is a great fit for tool servers. So deploying and scaling Python is super easy. There's no infrastructure management. No, I'm just kidding. It can require a lot of infrastructure management, right? And this is where Heroku is incredibly valuable. Heroku is a platform as a service, really in my mind, simplifies the process, offering several key benefits. Deployment is typically very easy. Git, push, Heroku main, it's up and running. It's pretty straightforward. We handle the infrastructure, the underlying servers, the networking, the basic configuration for you. Setting all that up by yourself is fine. It can be fun, it can be frustrating, but generally it's not a business differentiating sort of task that you're doing. Heroku uses build packs to automatically containerize your Python application, so that makes it very easy. Scaling your application horizontally, like we were just talking about, is often a matter of going into the dashboard and moving a slider, which I find pretty slick. And there's even CLI commands that you can do the same thing. There's integrated logging, which is huge to monitor your application's performance. All these things put together really showcases the ease of use and scalability that make Heroku ideal for your MCP tool servers. Hillary.
Cool.
All right. Help me welcome Hillary up to the stage here.
Alrighty. Let's plug in. Okay, cool.
Hopefully.
Let's copy paste some code. Okay. I'm psyched. This works. Okay, great. Is this text okay, or do you guys want bigger? It could be bigger? Okay. Let's see. Bigger. Is that good? Maybe bigger. Oh man. Okay. Maybe we'll full screen when we're doing the code stuff. That sounds good. And I'll make this bigger too. So because we are at PyCon, we're gonna demo deploying a MCP Python code execution repo. It's very similar to a ton of example MCP repos out there. If you go to like Model Context Protocol GitHub repo, their README is enormous, and there are a ton of example repos that you can test out. But basically, the code is very simple. It's like standard MCP with a couple files sprinkled in to make Heroku happy. So since people aren't super familiar with Heroku, there's a couple things. There's this optional app.json file, which is sort of like an extremely simplified Docker file saying like, hey, I have some config vars, like in this case, don't scale up a web dyno. In Heroku speak, a dyno, for what it's worth, is like a little machine that you're deploying to the cloud, kind of like an EC2 instance from Amazon. And we're saying here, like, hey, I want to use Python, so use the Python build pack. And then we have a proc file, which is sort of like saying, hey, if you are spinning up a web server, like, this is how you do it. And here is our MCP. That needs to be bigger. MCP server. So I want to take a look at the actual code before we deploy things. It's pretty simple. If you were to fork this and you want to deploy like your own tool server doing whatever, making drawings of unicorns, although I guess that's what models typically do, you essentially would just replace this file here, codeexecution.py. This includes a really simple function to run some Python code. So if we look down at the bottom, we just have this function, right? And just some doc strings, it's very normal. And then in here, set up tools.py, we're just using the standard Python MCP package right up here and saying, hey, I want an MCP server, and I'm gonna attach my tools to it. And so these are just like standard Python functions that you've written to do whatever you want. So very, very simple. And then we have 2 files to set up an SSE server and a Studio server. Actually, I have a branch out to set up the stateless streamable HTTP one that I haven't landed yet. But that's pretty simple. So let's try deploying it. And to do that, I'm going to use this magical button. There are also, in our docs in this README, there are instructions to deploy things manually, which maybe teaches you some things, but I really like buttons. Oh, joy. Lovely. I really like buttons because it makes things easier and deterministic. So everyone can check Reddit while this happens. Hopefully. Oh, great. Okay. Thank the flying spaghetti monster. Okay, so let's deploy an app. All I'm going to do here is I'm going to name the app and keep everything else as default. So I'm going to call this MCP-compliant. That is my app name. Keep these default configuration variables. In this example repo, we've added like a little custom middleware layer for an API key. MCP supports OAuth and not really much else yet in terms of authentication, which is tricky for deployed servers. I put in just a very simpler version of that because not everyone wants to deal with OAuth, but it's pretty easy to swap that out if you want. So what Heroku is doing, right, is just packaging this all up and deploying it. And once this is deployed, you can interact with it from Heroku or from any other LLM API that you're using. So here we have it in our dashboard. Stuff succeeded. Yay, yay. Let's test it out. So first, let's go here. And I'm just going to test out some things locally without the deployed server that we have. So locally, as Ken mentioned, there's a couple different transport types for MCP. The first one is studio mode, which is sort of like just saying, I don't have a server, nothing's running all the time. When I want to call a tool or access a model resource or do whatever that MCP does, I'm just gonna run all the code at once and do the handshakes and get back a response. So we don't have to run a server. We can just call something that says sorry, small screen. We're saying hey, use my example studio client that is using the MCP protocol and the Python MCP package. Use the list tools method and give me all the tools that we have. And in our case, right, we just have that code exec Python function. And it tells us the input schema in the standardized format that is now nice and agreed upon. So all of our AI applications can expect this same schema. So what's nice is Pydantic in Python, right, has grabbed our doc strings and injected them into the input schema in a nice way, so I don't have to duplicate that anywhere. So we have our different parameters and definitions. Yay, that's nice. And then if we actually want to call a tool, really similar. We're just saying, hey, I have my example client. I'm calling out to MCP, and I want to use the call tool method. And this is the name of my function. These are the arguments. I'm going to have it install NumPy and then print out 50 numbers because that's a very crucial task. Okay, so that worked. You can also do this with a local server, right? So what I can do is grab the API key from my app that was auto-generated, but you can just set it to be whatever you want. Now it's running a server. So the streamable HTTP and the SSE type servers, these are normal kind of long-running servers that maybe you're more familiar with, where it's running, you can deploy it to the cloud pretty easily, and you can hit it with requests. For the stateless streamable HTTP, like Ken mentioned, you can actually hit it with curl requests, which is very nice. Okay, so that is really small again. Okay, so let's try this again. Same thing. We're just using an SSE client this time, but we can just list tools Oh, that didn't work. I have to get my API key. Cool. Same thing, if you can see this. We're just telling it, use my example SSE client, list the tools, and we get our output. Same thing with calling a tool. So next, let's do this with our actual deployed server. What I'm going to do is I'm going to tell Heroku to actually make a web server that's running. By default, this repo, if you clone it and run this stuff, it will not run a web server that will just bill you for a year, and then you'll get an annoying bill, because that sounds bad. Some people only want to use studio mode, and we have ways to like run studio mode in one-off dynos so that you're only billed when a tool execution is actually happening. So here, I'm saying Heroku PS scale web equals 1, and that's saying, hey, I have a web process that we define in our proc file, and that's our SSE process. I want to scale my dynos up to 1. And so if you want to do horizontal scaling, right, you could make this number 10, and you'll have 10 web servers that are all can all be accessed at the same URL. So when this happens, we now have, a like deployed SSE MCP server. And so what I'm going to do is I'm going to say, okay, well, like, what is the URL of my server? Because I don't know. So I'm going to ask Heroku, and this is it. This is the URL. And so now we can hit it just like our localhost SSE server, except it's deployed and scalable. So if we go back to our like curl questions, we can call the tool, and this time it should probably take like a second because it has to install NumPy for the first time. So it's going to be a little bit slower because that's hitting the server. And oh, I didn't shut this down, so maybe I'll do it again to be more convincing. Okay, so question for the audience. Can anyone tell me why maybe this is a terrible idea? Bueller. Yes, indeed. It's a bad idea. Yeah, so if you have this like shared multi-tenant SSE server hooked up to LLMs that can run arbitrary Python code, you are going to get malware installed. LLMs are extremely vulnerable to prompt engineering. And if any of your LLMs either make a mistake or have any untrusted input, you can sort of consider your server compromised. So you either need to do a very good job of like isolating every tool call request for tools like this, running arbitrary Python code, or maybe you don't want a shared multi-tenant server. So I'm going to talk about some cool stuff you can do to get around this next. So one thing you can do, you can like deploy this tool server. And any other AI application you're developing, you don't need to be using like LLMs through Heroku can access it. But some of the stuff I'm going to show you now is a little bit more Heroku specific, but can still be used with external clients. So I'm going to install this plugin that we released literally today. So it's an AI plugin. And what I'm going to do is I'm going to say, okay, I have my app, and I want it to be able to access Claude 3.7 Sonnet. And what is happening when I do this is because we have a proc file that has that MCP studio server process, and it starts with MCP, Heroku's basically paying attention to this and saying like, oh, okay, I know you have an MCP server. I'm going to call a list tools request and register your tools and keep track of them for you. And then I'm going to know that this model here has permission to run this code in one-off isolated secure dynos if you tell it to in like a tool request. So let's try doing that. I'm going to export 2 variables, which are configuration variables instantiated in the app when you add this add-on. So like, oops, shouldn't have done that. Wrong one. It's okay, I'll delete it afterwards. We have rate limits. It's all right, you guys. Cool, so I'm gonna, please don't fire me. Or I'm gonna do this request. So this is basically saying like, hey, Heroku, I'm gonna ask your V1 MCP server's endpoint, what tools do I have access to if I'm like using these add-on creds? And this will scroll because the screen is small. But it's essentially telling us like the list tools output with some special stuff. So it's saying like, hey, you have only deployed one server. But if you can imagine, maybe you've deployed like 20 MCP apps and 30 MCP servers and like hundreds of MCP tools, and all of them will be like registered and tracked here with the statuses. And so you can connect these creds to like external clients like VS Code or what have you, and have access to those kind of secure deployed tools that only bill you when they spin up these one-off dynos. And then similarly, what we can do is use our V1 agents endpoint to have these tools run automatically, which is kind of snazzy because typically if you call out to like an OpenAI like API, right, and you're like, hey, dude, GPT-4, you have access to tools XYZ, and it's like, wow, I really need to use tool Y. And it sends you back a response saying like, please call this tool Y for me. And so you have to catch that as like the AI programmer, like with the AI application. You have to catch that response and then figure out how to call the tool, which is what MCP is really useful for because now there's a standardized way to do that. So maybe you like call out to a deployed MCP server, and then you get that response back, and then you send it to the LLM. The LLM is like, oh, great, this is the output of tool Y. Now I'm going to think about it and generate my response for the user, right? So you have to handle all that back and forth. This endpoint, and that gives you a lot of flexibility and power, to be clear. If you don't want to have to deal with that, you can use an endpoint like this, which will sort of do all of that magically for you. So here I'm going to say, let's see. I'm just going to say, hey, you have access to this MCP tool that we've deployed right now, right? What's the input schema? And so as you can see, like we're not putting the input schema into the tool call request, or sorry, into the tools parameter like you normally would. It's just injected for you because we've registered the MCP server like with Heroku. And so it will come back, hopefully, eventually. And it was really slow. Did I do something wrong? Maybe. Should come back and tell us what the schema is. But we're live and it's not. So that's exciting. Hee hee. Okay, it did. That was real slow. Okay. So it came back in it's hard to see, but like it has the schema that is injected into it, so it's aware of what's going on. And similarly, we can ask it to actually execute something. And again, like this is not actually calling out to your SSE server that is shared multi-tenant. It's like spinning up these Heroku one-off dynos, which is kind of nice. Okay, so here we're saying, what is the SHA-256 of the string purple Python? And of course, if an LLM doesn't have access to something like code exec, it will just probably hallucinate a totally fake string, typically, and tell you that it's definitely right. But in this case, it has access to our tool server that we just gave it. And so all this stuff is happening on the back end. First, it's saying, hey, I want to call this tool. And like, here's the code I've written, and I want you to, import hashlib and blah, blah, blah. Then Heroku's catching that and saying, okay, great, we're aware of this tool. We know the studio process. We're going to spin up a one-off dyno, run it, and then send the output back to the model. The model reads it and is like, okay, great, the output was 932, blah, 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 and that's actually the right answer. I mean, I hope. But no, it is, I checked. So that's pretty cool. And I'm probably running out of time soon. The one other thing I will mention is if you do end up wanting to use this endpoint, we also have just some like Heroku tools that work without having to deploy anything, like reading PDFs and accessing your read-only databases and stuff like that, which can just be nice and like kicking off arbitrary pipelines or methods on like a machine that you have deployed already. And these just kind of work out of the box in the same way. You just specify a type like Heroku tool instead of MCP. So that can be nice, but more fun to maybe deploy your own as well. So we'll see if this is still slow. I guess we did GA today, so it's possible that our servers are acting slow. Anyways, same thing happens. All this stuff is happening on the back end, and you get the final response, so you don't have to like deal with. I mean, LangChain is awesome. You can do that. You can like handle all these things yourself. But if you want to have like a pretty simple process, it is nice to have all of this stuff happen on the back end and just get the final response. Alrighty, so that's it for demo stuff. Questions? Yes.
Why don't you come up to the mic so that because we're recording.
Oh yeah, sorry, I forgot they told us to ask for that. I see two people. Do you guys both want to come up and ask in sequence or something? Okay, amazing.
Yeah, so I haven't worked really at all with MCPs, so my question is kind of about you were showing a step where you can get the schema of what tools are available, and I was wondering, is that part of the MCP definition of the MCP protocol,
Yes.
or is that something with Heroku?
No, that's totally MCP. Yeah, so like the server that we've deployed is like an official MCP server. Like you can use it with other MCP clients, like not Heroku. And MCP specification is specifically saying like there's a like list tools method, and you get that output with the schema. And so different like LLM APIs will have different ways of ingesting input tool schemas. So it's like a lot of them, I'm guessing, are going to start allowing MCP. But the idea is like if you all have tool servers with that schema, then it becomes easier to translate at least like all your servers to whatever API you're using.
Hey, so yeah, I'm also not too familiar with MCP, but you gave that example of like, okay, we obviously don't want to run this untrusted code on this shared multi-tenant server, but like,
Indeed.
there's also cases where, you know, even let's say you spin up some instance that's private to like one LM invocation, they still could be doing something privileged with the tool, like, you know, accessing some privileged information. How do we get the auth into the LLM so it can make that call?
I think, well, the key is not giving the LLM the auth ever, because the LLM is very prompt engineerable. So I think you want systems in place to have auth around it that the LLM doesn't have access to. So sort of like you have your AI application handling, like calling out to an LLM, and it's also handling calling out to tool servers. And so it should have like OAuth or systems in place to figure out like what permissions it should have access to, like what tools it can run, and like safety there, right?
So it's like safety at the layer of accessing the LLM in the first place, then the LLM is like fully privileged, or?
No. So I'm saying like, so like you don't want to give like authentication keys to LLMs, right? Because if you have untrusted input, LLMs can do whatever. But you can say like, hey, I'm the AI application code author, and I know the LLM that I'm running like should have access to like these tools. And so I'm not going to tell the LLM like the keys or anything, but like that I'm going to tell the LLM that has access to these tools. It sends back a request and says like, okay, run this tool. And then I tell the servers, hey, here are the keys. Even though the LLM isn't aware of them, like here are the keys, and run it securely, and then send back the response. And so you can do that yourself, or in like our demo case, like you can have Heroku do that all for you. But I'd say like typically you don't want to be sending your LLM your creds.
Okay, so then like how do I tell that like the LLM that is calling the tool has the ability to call it? Like I would just be creating a tool, and then anyone who like I would have like that proxy step, right? But like I'm still not connecting. Sorry. Maybe we can talk later. I can do some more reading.
No. I'm probably not explaining it right. So, like in the case of the demo, like with the Heroku stuff, or more generally?
Just like more generally.
So if you're like the author of your AI application code, right? You have like full power to decide what tools you're actually calling, because LLMs don't execute tools. They send you requests to execute tools, and then you execute them for them, right?
Oh, okay. So it's not like a server. Like I'm not spinning up like a public API that, you know, maybe might be reusable across applications. This would all have to be bespoke to a single application.
So I think something that's often confusing about MCP and this stuff is people say like, oh, LLMs like call out to the tool server, and they don't. Like LLMs generate text, right?
Okay.
You get text output, and then you have to build applications that take that text output and do stuff. And in this case, like, you know, that doing stuff is
okay.
like calling out to tool servers in a secure way. But yeah, so they're just outputting text. Like they don't have kind of actions built in natively to them unless you're using a service that sort of like has that infrastructure
Yeah,
already in
that
place.
might be where the mismatch is.
Okay,
That
cool.
makes a lot more sense. Thank
Awesome.
you.
Cool.
I'm curious if, let's say you have an LM client and you give it access to like 50 MCPs. How does the client know when to send a request to which MCP and whether it needs to even activate an MCP in a given, to answer a given question?
Yeah, good question. So that is the LLM's job, right?
Yep.
Because you're telling the LLM like, hey, I hope you have a long context length,
Yeah.
because here are 50 tools with
Yeah.
complicated input specs. So the LLM has to be like, okay, great, like hard pass, I'm not calling any of these, or like I want to call these 3 or whatever.
Yeah.
And so it sends you back, right, what it wants to call, and then it's the client's job to, or Heroku's job, whatever, to actually execute those if it has permissions.
Gotcha. Okay, that makes sense. Thanks.
Cool. Yeah.
I actually missed a lot of your session, so in case you've answered, but I really want to hear an answer. That's why I'm like, let me take the risk. I have been working mostly with LangGraph, LangChain, LangSmith. I don't think they've taken MCP that seriously yet. So I have been exploring MCP with Anthropic, but not using the API approach, using the Anthropic Cloud desktop app. And right now, I have to do everything local. I'm guessing what you're showing is that I can have my server running on Heroku Cloud, right?
Yeah,
Good.
exactly. We actually, so there's some Dev Center articles on this. And
Yeah, I was going to say, should I come to you after and get all the links?
yeah,
of where to go?
probably so. Because if you want to, it kind of depends how you want to run things. Like if you want tools not running in like secure, isolated environments, which you really should for things like code exec, then you can like deploy an SSE server and like hook that up to Cloud Desktop or like Cursor or something like that. If you want it to run in the isolated instances, we have some shenanigans to basically run it in one-off dynos via studio mode and then translate that back to SSE for tools like Cloud Desktop. So we have some like Dev Center stuff on how to do that. But yeah, that's a good question. It's not something we went into or
It's
demoed
okay
at all.
if I stay by and try
Oh,
and get
yeah.
links, right?
Completely, totally. Cool beans. Any other questions? Nope. Alrighty. Thanks, you guys.